All right, we're going to do section 3.5. Number 3 said, when is f of x, which was this parabola, greater than 0? Okay, so they're talking about the y value here because they're talking about the f. And for what x's does f, the y height of this parabola, be greater than 0? Well, there's the y height is 0. The y height is greater on this and that, say, wings, if you will, of this parabola. But it says for what x's? Well, for all the x's over here, this way, put into this f, this parabola is higher. And also for all the x's over there, the parabola is higher. So we'd have to say from negative infinity up until x became -2, the parabola is greater than 0. Also, the y height is greater than 0 from 2 to infinity. So when is it the y height less than or even equal to 0? Well, it's equal to 0 at those two places, and the y height is these negative values. It's less than 0 for all these x's in here. So I'd answer this one saying the x's have to be between -2 and 2, and I can be equal to those also. So there's the answer to 3. Now 5 says, when is the g graph, the line, the y height, the height of g, above the f? Well, g is higher than f only for these here. The line is above the parabola from here in the x direction to here. So it happens when x is between -2 and 1 and equal at those, so we can include those. When is f above g? That would be for all x values out here, f is above g. And so that would be from 1 to infinity. And I can't be equal, so I don't include the 1. It's also, f is above g out here from -2, negative infinity to -2. There's the answer to 5. Answer to 7. When is this parabola, if this was y or f of x, and I drew a graph of this parabola, which would have to be a right side up parabola, wherever it sits, where it crosses here, these wings would be above 0, and since I want to be below 0, I wouldn't want to use these x's, but for all the x's between the two x-intercepts, this parabola is below 0. So I need to find the x-intercepts, and I think I can factor this to find it, or I could use the quadratic formula. And now I'm only interested in when it's equal for a moment, because I want to find these two places. I know the answer is going to be between to be less than, but I got to find the two places. So I'm doing equals. And this factors to x and -5 and +2. So that makes -5 plus 2x makes -3x. -5 times 2 is -10. And so x equals 5 or -2. And quadratic formula would have given me the same answers if I put that in for B, 1 in for A, and -10 in for C. Should have got the same numbers. So this must be the -2, and this must be the 5. And so my answer for when the parabola is below 0 is for not in -2, it's equal to 0, so I want to not equal it, but go between it and 5. There's the answer to 7. 9, now we got a parabola, it's right side up, and we want to know when it's greater than 0, so that would be the wing and the wing. I just have to find out when it's equal to 0. This factors quite easily. X comes out and it becomes x minus 4. And so x has to be either 0 or 4. So this must be the 0 and this is the 4. And I need to be below it for the parabola to be above 0. So I got from negative infinity to 0, union 4 to infinity. 12. Now I want the part of the parabola that's below the x-axis, and this is a right side up one. So I just got to figure out where it is, and the part that's below will be between those. This factors to x plus 1 and x minus 1. And so, and I'm again looking for 0, so this would be negative 1 or 1. And that's these two places. The part of this parabola that's below 0 is between those. That's negative 1, that's 1. So it would be, and I want strictly between, not equal, so it's going to be from minus 1 to 1. 14. I want the part of the parabola, whoa, let's move the 12 over so we get our parabola and have it equal to 0. So this is a right side up parabola and I want to have it less than 0, so I'm going to be using the point of it here. I just got to find these, so I'm going to figure out what makes it equal to 0. This factors to x plus 3 and x plus 4. If I set that equal to 0, I get x equals negative 3 or negative 4. This would be the negative 4, this would be the negative 3, and the part that's below 0 is between those. So from negative 4 to negative 3. 15. So I'm going to go get this equal to 0. So it's a right side up parabola and I want to be below 0, so it's going to be between the two intercepts, so I got to use quadratic formula or factor. I'm going to try factor 2x, x. Let's see, if I do negative 3 here and 1 there, I get negative 6x plus 1x is negative 5x. I get negative 3 and I get 2x squared. I'm trying to make these equal to 0 to find these intercepts. So this one, if I set it equal to 0 and subtract 1 divided by 2, I get x equals negative 1/2. Or from this I get x equal 3. So this is the negative 1/2. This is a 3. I want the part of the parabola that's below 0. So that's between them. So it'd be negative 1/2 to 3. Not including them because it's not equal. And finally 21. So I have 6x squared minus 5x minus 6, and I want the parabola to be greater than 0. This is right side up one, so I want outside of this is where it's greater. It's above 0. See if I can factor this. 3x and 2x, does that work? And if I do 2 and 3, that's 9 and 4. If I subtract them, which it says to do, I'll get 5. So I want to be negative 5, so I'm going to have minus 9x plus 4x. And so if I solve this, setting it equal to 0, I get x equal, subtract 2, if it's equal to 0, subtract 2 and divide by 3, so negative 2/3. If I solve this, add 3 and divide by 2, I get 3/2. So this must be the 3/2, and this must be the negative 2/3. And the part of the parabola that's above happens for x is bigger than 3/2 or less than negative 2/3. And that's the ones you had questions on.